Hello Info-Person, this is Anton, and today we're going to be discussing a discovery that's as beautiful as it is confusing. A galaxy that looks like a giant cosmic bullseye. The galaxy you see right here. And though you might guess that this is something that's AI generated, in reality it's not. This is the actual image of the galaxy referred to as LIDA 1313424, taken by the Hubble Space Telescope. A galaxy that's now also known as the Bullseye galaxy. And this is technically what's known as a ring galaxy, a galaxy that kind of resembles something like this. Basically, it contains a huge ring around it. And well, as we've talked about in a lot of previous videos about these types of galaxies, these are actually ridiculously rare. Essentially, 1 in 10,000 galaxies resemble something like this. And technically, most of them are still kind of difficult to explain because in a lot of cases we have no idea how they actually acquired the ring. But in this case, there's actually an additional mystery. Most of these galaxies usually contain 1 or possibly 2 rings, and sometimes rings with somewhat bizarre shapes. Here's actually one of the most famous examples, the Whirlpool galaxy. But Bullseye galaxy is really extreme. As we've discussed in one of the previous videos in the description, here astronomers confirmed that it seems to contain 9 perfectly concentric rings structured in the way you see in this image. And this is completely unprecedented and is actually forcing us to rethink how some of these structures potentially form. As a matter of fact, as of 2026, this is still a bit of a mystery. But to understand why this is so extreme and why not a lot of explanations here make sense, let's first briefly take a look at other ring galaxies and how scientists believe they most likely form. And once again, let's start with the prototype, the Bose object, discovered back in 1950. Here it contains a central core filled with much older yellow stars and is then surrounded by this vast, nearly perfect circle containing stars that are extremely young, very hot, and very blue. And while between the core and the ring there seems to be almost nothing, almost like a dark gap. And for a very long time, the leading explanation here was some kind of a massive collision. Or in other words, think of something falling in the water. Here, the collision between water and the object produces these concentric rings as a result of the disturbance that transfers energy into the fluid surface. And so here scientists thought that many of these objects very likely have these smaller bullet galaxies passing through them, most likely directly through the center, that then causes the larger galaxy to create a kind of a gravitational shockwave that then spreads and creates new stars as the shockwaves creates overdensities. And well, the thing is, for many of these galaxies this does make sense, mostly because we sometimes even see the culprit, that bullet, somewhere in the vicinity. And so as the bullet passes through, the ripple moves outward, pushes the gas and dust along with it, and the compression of the gas triggers a massive burst of star formation, which is why we usually see these rings containing brand new stars that are extremely hot and extremely massive. But this doesn't seem to apply to all objects. As a matter of fact, going back to the Bose object, it still doesn't really make sense here. Mostly because the actual ring is a little bit too perfect and there's also no secondary galaxy anywhere nearby. So basically, where's the bullet? And actually a fun fact, if you look super close, you'll notice that there is another ring galaxy inside this ring galaxy. Although that tiny one is extremely far away, and so this is just an example of a perfectly accidental alignment. But going back to this 9-ring bullseye. First of all, this is a massive galaxy. It's about 2.5 times as big as the Milky Way galaxy and is approximately 570 million light years away from us. And well, here the initial proposition was essentially very similar. Some kind of a small dwarf galaxy passed through the center, most likely 50 million years ago. And the ripples generated very likely produced the rings. As a matter of fact, in this case, there is potentially the impactor galaxy nearby as well. It's a little bit more difficult to see, but there seems to be even a trail of gas connecting the two. And so here there was a kind of a smoking gun for what most likely happened. And so according to this model, each of these 9 rings is a separate ripple traveling outwards from the central impact. And though at first this of course made sense, this follow-up and this new study, the study by Pierre Sikivi and Yuxin Zhao, suggests that the math in this case doesn't seem to add up. In other words, this stone in the pond explanation might not make sense here for one simple reason. That reason being the outermost ring, which is approximately 230 light-years away from the center. And well, here's why this doesn't actually make sense. If the collision indeed happened 56 million years ago, it means that the ring would have traveled at over 1200 kilometers per second to get this far, which actually would make it much faster than some of the hypervelocity stars we find in the Milky Way galaxy. But in standard physics, when it comes to these ripples, the prediction is that they should be moving pretty slow, maybe about 55 kilometers per second maximum. And that's a discrepancy with a huge factor of approximately 20. So something here definitely doesn't add up. Furthermore, according to the collision theory, as these rings move out from the center, they should actually start overlapping and start to appear kind of blurry. Or basically they should resemble something like this. But in the case of LIDA 1313424, the rings are remarkably distinct and are also extremely sharp. So here even the shape of the rings does not match the predictions. And so because the collisional explanation contained these gaps, scientists started to propose other explanations, with the one in this study being particularly interesting and potentially somewhat exotic. What if this is actually caused by a specific type of dark matter? Something that we've been looking for a very long time, and something that scientists can only see through the actual effects, but not the particle that's causing it. And so in this explanation, it actually suggests that dark matter is not just some kind of a big fuzzy cloud, and instead it might form perfectly circular tubes inside the galactic disk, with these shapes being the result of the dark matter particles falling in and out of galactic gravity and essentially folding over each other, creating regions of much higher density. And so if this is true, the 9 rings observed in this galaxy are not ripples from the collision and instead represent a visible imprint of the dark matter interaction with this galaxy, with the gravity from these invisible particles pulling in the gas and dust that then forms the stars we can see in our telescopes, which would potentially explain why these rings are so perfect and why they're not moving at these impossible speeds required by the collisional model. But in order for this to be real, it requires a specific type of dark matter based on the idea referred to as axions. Once again, one of the videos in the description explains this in a little bit more detail. And so this proposition assumes that the dark matter is extremely light and essentially creates what we refer to as Bose-Einstein condensate, which is sort of simulated here. It's when a lot of different relatively light particles combine and start to act as the massive superparticle that we refer to as Bose-Einstein condensate. As you can see, it also creates these ripples. And so unlike collisional rings, here this potentially forms naturally inside galactic halos as a result of the dark matter's gravity and the vorticity caused by the galactic motion. And so in this case, the particles are not just moving randomly, they seem to be organized into a giant, slow-moving swirl and flow, which then generates these folds and these waves. And intriguingly, according to the authors, these 9 rings seem to actually fit the model pretty well, suggesting that these rings represent a fundamental property of the galactic dark matter that instead of a halo ended up forming this ripply structure. And if this is confirmed and if this is indeed true, this would represent extremely strong evidence for the existence of very light dark matter particles that seems to form these somewhat bizarre shapes in certain galaxies. And it would also mean that ring galaxies in general may represent a fundamental part of how some galaxies are structured, with dark matter basically causing them to form these bizarre shapes, which would also explain the Higgs object quite accurately as well. But this would not explain all ring galaxies, because we know that some of them definitely formed as a result of a collision, because we do see a galaxy nearby that passed through the center. But in this case, the dark matter explanation potentially solves the mystery of those perfect ring galaxies that do not make as much sense. And so, at least for now, the Bullseye galaxy remains a bit of a mystery, but also one of the most interesting objects discovered in the last decade. And so whether these ripples formed from some kind of a collision or represent some kind of a visible map of dark matter, only time will tell. Either way, it's clear that, at this moment, we still have quite a lot to learn about how these objects are formed, and why some of them look so extremely different from most ring galaxies we've found so far. But we're most likely going to learn more once there are some additional observations from this galaxy, and once we observe it in other wavelengths like the infrared, X-rays, and gamma rays. And so until then, thank you for watching, subscribe, come back tomorrow to learn something else. Support this channel on Patreon where you can find additional videos without any ads and can DM it directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.